Session 2 is actually going to be a panel discussion, but it's going to be led off by Scott Rea. Scott is the Vice President, Government and Education Relations and PKI Architect at DigiCert Inc., which is a global certification authority. The latter part of the presentation, Scott will also be joined by Kathryn Kerr from AusCert, Patricia McMillan from CODIT, and Sat Mandri from Tutakari. So I'll hand you over to Scott.
G'day folks. We heard a lot just now about massive amount of data that needs to be managed, and this next panel here is going to be focusing on some of the trust issues that are associated with knowing that you are at an authorised repository or facilitating the actual collaboration that's necessary to generate some of these massive amounts of data. I better just make sure this thing's working. Good. So primarily I'm reporting on some research that has been undertaken by some respective research institutions in the US, Dartmouth College and New York University. The panel, as were introduced just previously, they'll get up and say a few words afterwards about the impact of this potential research to the communities that they represent. To kind of set the stage, one of the ways in which data is managed is typically to leverage, through a browser interface, access to portals that give you access to the data. Now, by utilising a browser interface, you essentially are tying yourselves to the trust infrastructure that is embedded in the browser. And as we have seen over the last, well, about a year ago, the CAs, the certification authorities, who issue certificates that identify themselves that are trusted in browsers, were in the news for all the wrong reasons. And it actually caused quite a lot of concern for all industries that rely upon certification authorities and the trust that comes through browsers. Now typically, for the purposes of this presentation, you'll see a term that I'll utilise called an ICA, and I'm referring to an Internet Certification Authority. And what I mean by that, I mean an organisation that is actually trusted either in the browser or the operating system that the browser relies upon for identifying websites or individuals or actual code, any of those or any combination of those. They're actually utilised to set up encrypted tunnels that allows data to go over the internet in a protected way, encrypted such that nobody can casually view it and only the intended recipient has access to it. As you can imagine, when you're dealing with research data, there is massive concerns around intellectual property in the creation of data. And when you have systems that are configured, like was in the previous presentation there at CERN, where physicists are creating massive amounts of data, they utilise trust infrastructures that rely upon the CAs that are trusted in browsers and operating systems to facilitate exchange of data and creation of data. So that ICA that we're talking about are those Internet Certification Authorities, those that are trusted in browsers or the operating system. So the CAs were in the news for all the wrong reasons. I don't want to go through the list because we're a little short on time, but essentially there were a number of breaches of the trust infrastructure. Essentially what it came down to, however, was not necessarily a technical failure. It was not a technical failure in most cases of the organisations who are operating the trusted CAs. It was actually the implementation of their processes and procedures that are meant to protect the technical aspects that were typically at fault or not implemented correctly. But as a result of that, there was a large concern that was raised to say, look, this is broken. We had like 7 or 8 of these things that were in the news for all the wrong reasons, and people were saying, look, the sky's fallen, we can't trust any of this anymore. One of the issues here is that if you take collectively as a whole across the major operating systems and browsers that folks utilise, there's probably about 200 to 300 in that range of certification authorities globally that are trusted across those. And the point that a lot of folks were making was that, well, if I'm a researcher, which of those should I be using? It's obvious based on what we've seen happen that some are more trusted than others. How to identify who's more trusted, and do we not have a fundamental issue here where if I want to attack that system, I'm not going to go to maybe the top 10 or 20 who do things right. I'll just go to one of the other 290 who aren't doing so well. They're equally trusted in the browser, and I can fool researchers into giving me up their data, or I can get a jump on what it is that they're researching. And so the typical method of attack that is used here is called a man-in-the-middle attack. And essentially, if you manage to subvert one of these CAs to issue a certificate that you're not entitled to, and you can pretend to be, maybe it's a university resource, maybe it's a resource at CERN, etc. You have a certificate that would be trusted in someone else's browser. You're pretending to be that resource when you're not. When they connect, you capture their network traffic so that they come through you, and then you just mirror everything that they're talking to you back to the site. So to the end user, as far as they're concerned, they saw that they're trusted in their application in the browser when they're connecting. They think they're connecting to the site. They're actually getting data back that they expect to be getting back, but there's actually somebody who's in the middle reading everything that's going backwards and forth. This is a massive issue. So one of the things that we want to do is discover whenever one of these attacks is taking place, and if one of these attacks is taking place, be able to revoke the credential that's being used to do that so that it's no longer trusted. I think it's unreasonable to expect perfect security, because that is never going to happen, but what we need to be able to do is identify when we're under attack and be able to respond to that in real time and be able to take advantage of that in the system. So, the CAs were proposed. There were a number of proposals to replace the CAs because supposedly they were broken. One of the concerns that was raised, however, was there was a lot of henny-penny running about the sky is falling and not too much evaluation or analysis on what was being proposed. And a few of these popped up, and there's 8 or so that are listed up there on the board that this research that's coming out of Dartmouth and NYU were evaluating in terms of, A, are they really an appropriate replacement for what we have, or are we putting the cart before the horse here? So the 8 proposals to replace the global CAs for a trust infrastructure, as listed there: perspectives, convergence, MECI, DANE, public key pinning, sovereign keys, CAA records in the DNSSEC, and certificate transparency. Some of these you may have heard of. And the paper that was produced basically said, look, let's, rather than having a totally subjective message here, let's try to understand what the pros and cons of each of these are and ascertain and analyse whether they are, in reality, a good replacement for the existing CA system. And obviously there was no framework in order to do that analysis, so some had to be invented. And essentially this passage here describes the framework. I do want to say that I am going to go through slides fairly quickly, because I've actually lost my track of time here. But there will be a lot of data in the slides if anybody wants to follow up on that. So there was basically a metric established, a set of criteria for evaluating these 8, and let's run everybody through it and let's see what comes out the meat grinder at the other end. And having said that, at this point, I have a number of disclaimers up here, because the idea behind this research is that, number one, it is still a work in progress. It's still ongoing. The idea behind the research is that it would be a starting point, and we want to make sure that what we end up with, that research continues, which is why we have some of my colleagues here who are going to talk about their perspective on it. To quickly run through what the categories were, there were 11 categories that were listed. Again, we don't necessarily have time to go into the categories because it's probably an hour-long presentation in itself, but nonetheless, these were the things that were the most often quoted reason behind why we need to replace the existing infrastructure. And there was an analysis performed with a ranking of the categories down the bottom there. And as you can see, this is kind of how the ranking came out at the end. Looking at that, some things for statisticians should pop out immediately. They're grouped fairly close together. That says that you probably don't have a broad enough analysis. But basically, what came out of it was, out of the 8, there was probably 2 that were more enhancements of the existing system, as opposed to complete replacements of the existing system. And it turned out that the complete replacements didn't really stack up according to this criteria. The ones that were enhancements performed fairly well in the analysis. Oh, there we go. So, again, the industry has looked at this. Again, it's a starting point, but essentially, when you stack those 2 that we mentioned there up against the existing system, how does the existing system came out? Basically, the analysis that was coming out of Dartmouth and NYU was that the existing system, if you enhance it a little bit better, is actually better than anything that's being proposed currently. One of the criticisms of the initial pass on this is that of the 11 categories, they were all given the same weighting, and so some further research was done that allows you, if you wish, to apply your own weightings to those categories and then see if that changes things. The interesting thing was it didn't really seem to change the outcome of the analysis. Basically, at the end of the day, we don't necessarily have anything that today is ready to take over from certification authorities as a trust infrastructure, as long as we implement changes to fix the issues that have been highlighted, basically. And I'm going to leave it there because I'm close to my time and give my colleagues an opportunity to provide their perspective in regards to their organisations, and then we'll have a few questions at the end.
Thanks, Gus. My name is Kathryn Kerr. I'm from AUCERT, and AUCERT operates a certificate service for the higher education and research sector, and we use the services of a ICA called Komodo to provide much of that infrastructure processing and support. However, I have as a middleman in this process of helping universities in Australia and New Zealand to purchase certificates for their use, some experience with dealing with the web hosters, domain owners and the relying parties. So from my perspective, I read the paper and concur with the guideline, the conclusions very much. While I certainly encourage research into new complementary ways to improve the PKI system, examination of the facts surrounding these matters indicate that we do have a rather robust system. It's far from perfect, but there are factors that have been identified by the CAB Forum, which is a self-regulating group. If we've got time, maybe Scott can talk a little bit more about that, but who are actually taking initiatives to improve the current perceived weaknesses and actual weaknesses of the existing ICA system. In particular, I see have some experience of that based on my dealings with the hosters and relying parties. And in particular is the implementation in the software, the operating system and browsers. I think there could be better improvement in the way that these various PKI software products detect revoked certificates, the frequency, the speed, and so on. And I think that would close, it would reduce an exposure. It's certainly not a complete solution for the man-in-the-middle attacks, but it would reduce when a compromised certificate has been detected. It would allow at least those who are relying on it to know more quickly. So I think that is one thing that could be addressed. There are some other examples of where the implementation could be improved. The processing is definitely a factor as well, and we're definitely seeing improvements based on the outcomes of the CAB forum and in terms of our own dealings with Komodo. And I've gone over time, so I'll stop there.
I'm getting the out of time signal, so I'll be very quick. I'm from COD at the Council of Australian University Directors of Information Technology. Scott asked me to talk about why this is important to CODIT. CODIT represents all of the chief information officers and IT directors at all the universities in Australia and New Zealand. And the reason that this conversation is important to our members is that their role has changed very much from being a provider of services to their universities, where everything was provided from within the university, to being a broker of services that come from outside the university. So increasingly, all of the university services are outsourced to someone else. Not all, but it's certainly moving in a huge way to in that direction. And so it's really important to our members to know that when they access all of their critical services that are very important for running their university, that the sources that they go to are who they say they are, and they're not being compromised, because even though those services are run by someone else, if there is a breach, then the responsibility comes back to that CIO. And that's why this is important to CODIT. And I'm really happy that this conversation is happening.
Thanks, Pat. South Mandri from Kerr, the Service Manager for the New Zealand Access Federation. Upon Scott's invite to actually join this panel, I see the New Zealand Access Federation and similar bodies as being the end user, where we come to and consume services of providers like OSCET. These certificate services authorities as such are pretty much kind of given a community service, and we as users actually have an expectation that what we buy, what we get, we actually pass that on and build it within our service and deliver that to our customers, our users, actually have that baseline security, and the expectations that they have for security are actually met and delivered. While there is opportunity for always continued analysis and to better the security levels and criteria, I think there's always opportunity to look at the analysis and forge ahead to actually ensure that the necessary safeguards are in place to achieve what the desirable levels are with regard to security, whether it's going to be your application, your services, or the wider research data we're talking about.
And with that, do we have any questions?
I absolutely support that anything can be done but there's much that can be done at universities for access to services that are supposed to be secure. For instance, secure ID tokens are used by most unis for access. That does nothing to solve the problem we've been talking about here. They're subject to man-in-the-middle attacks. Yet hardware smart card doesn't have that vulnerability. At least I believe so, though you perhaps know better, but are harder to deploy. So much of this can be solved for the services which need security now.
Yeah, it's always a trade-off between costs. Security is a trade-off between costs and risk, and you've got to strike that balance. We certainly have technologies that will allow us to solve this, but if you had perfect security, you'd get no work done either. And so you've got to find that balance that works, that keeps enough of the risk away, but implements technology, and hopefully the cost of technology comes down, that makes it economic to implement it. But yes, you're absolutely correct. Very good.
Anyone has one? For the panel? Sure.
If you're relying on a browser, the browser to
security, then it's going to happen. You're going to get violated. You're going to get the trust that you just assume is implicit on the clever techies who build this stuff will be broken. It will break down. And I guess the main issue is because it's not so much the authentication, which is what your certificate is being used for, signing in. It's actually how you do authorization. How do you define and ensure your research data, your licensed intellectual property, is protected from someone accessing it over the web through a browser? And until we nail that one down and agree on the best practice and standards, your authentication systems, your cross-signing certificates, are just going to be a very short, easy way to do certain types of things, but fundamentally not solve the harder problem what researchers want in protecting access to their resources in a proper, scalable, manageable manner. Who can see my data over the web, kind of thing.
Yeah, you're exactly correct. Once this research analysis is complete, this is talking about foundational services that you can build trust on, but when it comes to who has access to your data, it really is going to come down to the authorization model, and that is a much larger issue that there are a number of research issues that are there that need to be addressed, and we're obviously in the community that can do that, but that will be addressed based upon this base level of trust services being taken as a given, and we're not at that base level yet. And so, but you're absolutely correct. From here, we need to then focus on what the authorization mechanisms are and how they're implemented, because there are a number of potential subversions that can happen in that piece of the equation as well.
Okay. Well, I just ask you to join me in thanking Scott, Kathryn, Patricia and Sat for their presentations this morning.